So this video is now about shifting the parabola. So you notice we have some parentheses here and we've thrown some numbers in them. So if you remember before, if we put a -2 next to the x like this, it would shift it to the right 2. So that means our vertex is now at 2 instead of 0, because we were at 0, shifted to the right 2 would be 2. And our y is done the same way this time, and so now it's -1, so this would become a +1. So all you have to do is take the opposite of these numbers, and that is your vertex. So 2, 1 is our vertex. So our parabola is going to look like this or this, depending on the function that we're dealt with. It's 2, 1. So the next thing we need to do is find the focus. And if you remember before, it's whatever one's not being squared. So this is everything about the x. So when we say 4a equals 4, our a equals 1, this belongs to x. So to get the focus, we're going to take that and add it to the x. So our focus is at 3, 1. So we go to 3, 1. And you can see it's now opening in the x direction. That's what's going to happen here. This is the x direction. Okay? So the directrix would be on the other side. So if you subtract 1, it gives you the directrix. So right there. But I'm just going to write it 1 unit away. All right. So now it's the same as before. If we had a 1, our next point would be up 1 from the vertex and then over 2. Remember, we just double it. And there's your graph. Oop, that's 3 right there. And you can see there's our nice wide graph. So it's that same idea. This is always 2a is that distance here, right? And there is always 2a. And there's our graph. All right, so let's look at Desmos to see this a little bit more. So here is the function we were dealt with. It's not really a function anymore, is it? Because it's not a function. This is the equation we were dealt. And you can see now that our focus is at 3, 1. And our vertex is at 2, 1. So it's 2, 1. And since our a here was 1, you see a is 1. It's 1 unit away and then up 2, down 2. So if we were to just modify it, make a 2, right? You can still see the focus is still 2, 1. But now it is 2 units away. So I've added 2, subtracted 2 to get to the directrix. And if that's 2, then that would be up 4. So you can see it's 1 plus 4 is 5. So the h is next to the x, and that's going to move it left and right. And the k will move it up and down. See? And the a will make it compressed more than it was before, right? The larger the number, the more compressed it gets. But again, this is a 12. So 12 divided by 4 is 3. So you can see now that we are 3 units away. And 3 times 2 is 6. So 6 units up. See, 1 plus 6 is 7. So all you have to do is use those 2 points to make the vertex. Find the a and then go out that amount and double it. Let's try another one. So our vertex here is 0 because there's no parenthesis, comma 2. So that is where we would start. And this one now opens in the y direction. So 4a equals 16. So a equals 4. This guy belongs to y. So in the y direction, we will go up 4 to get to our focus right there. And so that would mean that you would add 4 to this to get 0, 6 for our focus right there. And so the directrix is the opposite direction, so we count back 4 and draw a line. And then, like we said before, we double it. So 2 times 4 would equal 8. So we got to go 8 units out. 1, 2, 3, 4, 5, 6, 7, 8. And then 8 the other way. So to here. And then there is our graph. All right, let's try another one. So here it would be 0, -1. Right? And this one again is about who? It's the x. So this will open in the x direction. So 4a equals -8. A equals -2. And this one belongs to x. So again, we plot 0, -1. And our a goes in the x direction. So it would be subtracting 2 here. So at -2 minus 1. Right there. See, it goes in the x direction too. So that's saying a is 2, x, everything's about x, so it goes in the x direction too. And then our directrix would be on the other side. And again, we double our a. So our a is 2, we're going to go 4. So 2 times 4, sorry, 2 is 4. 1, 2, 3, 4 dot, 1, 2, 3, 4 dot, and then you make a nice wide graph. And it's that quick each time. So those 3 points are giving it to you. Your H, your K, and your A are allowing you to graph these nice wide graphs, nice and perfect and precise. All right, what if it's in this form? Well, this is when we get to use completing the square. So how you start it is you bring everything over to one side, just like this. Okay? Just like we have it here. And then what we're going to do is sort. So on the left side, you want everything to be y, and on the right side, you want everything to be x. So anything with a y stays on this side, and everything with an x goes over here. And the reason that is y squared. So when you look at these, the y squareds are all by themselves, or the x squareds are all by themselves. All the other junk is on itself is on the other side. So this is how you set it up. I like to bring everything over and then take everything that is not a y onto the right and everything that is a y squared onto this side. So there's all our y's. And you're going to put a parenthesis around it. And the next step happens every single time. It's just a nice pattern. So we're going to take this and complete the square so that we can factor it. So if you take that 4 and you cut it in half, so half of 4, that would be 2, and it's positive 2. If that was a negative 4, that would be a negative 2. You're then going to take that number and square it. Even kind of tells you right here, it says 2 squared. And you would get 4. Now with any equation, whatever you add to one side, you have to add to the other. And now we have our nice completed square, y plus 2 squared, just like this. See how it's y minus 1 squared. So the left side is done. Now we just have to deal with the right. So this would be negative 12x plus, and then that becomes 36. And if you look at the next part, you notice it's x all by itself. So basically whatever's in front of that x, we're going to factor it out. So what's in front of the x? Negative 12. So that is what we will factor out of it. So if I factor that out, I get x minus 3. So now we can see that our vertex is 3, negative 2. So our x, y. And our 4a equals negative 12. So a equals negative 3. And that this belongs to x because he is the one that is not squared. So I will subtract that 3 from the x, giving me 0, negative 2 for my focus. So 3, negative 2 right there. And my focus then would be 3 units away in the x and 3 units away from my directrix. And we know our point then is 6 because 2 times. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there is my graph. It should be 4 units up from the x-axis and 8 units down to give me my nice graph. But those 3 points should be nice and visible on there. So let's now check it in Desmos. So there is our completed the square form. We have our plus 2 and our minus 12 and our 3. So you can see our vertex is at 3, negative 2. And then dividing that by 4 would be negative 3. So negative 3 away would be 0. And then up 6 because we got to double it. And down 6. So everything's perfect. And then now all I have to do is plug it in. So I've got y squared plus 12x plus 4y equals 32. And if I click on it, you can't see it because it's there. See? It is the same graph. So that verifies that our completed the square form is exactly the same. Okay, the last one is yours to try. I just want you to try it. If you don't get it, the answer is going to appear and you'll be able to see how to figure it out. But give it a shot. Hit pause now and try. I know that was mean of me to have you do this yourself, but here we go. If you did it, you're great. So how this one's different is you now have 13x squared. And so to get rid of it, we divide by 13 to everything. So we end up with this. X squared equals 8 over 13y plus 9/13. And then whatever's in front of the y, that is what you're factoring out. So this and this. And so we factor that out, leaving us with this. And so we now know our vertex is 0, negative 9/8. And our 4a equals 8 over 13. But none of that really matters because once you get this, you realize, why would I want to graph this? And you wouldn't do it by hand. You would use a graphing utility. Or you'd use Desmos. So this is what it looks like in Desmos. And you can see that I've already graphed the other one with it. But it's just an exercise in practice. That's it. It's so you had something horrible that you can figure out. But there you are. That is everything. You now have a note page with everything about parabolas. Thank you.